Assalamu alaikum. This is video number 439, and in this video I'm going to explain the consumer's problem. I have already discussed the utility function in the previous video, and I combine all the 4 or 5 videos in this video to explain and discuss the uh, consumer's problem. So in order to understand the consumer's problem, we assume that there is a consumer who has a consumption set X, who is a consumption set X in a non-negative orthent, and that contains all conceivable alternatives or consumption plans in consumption. The consumer preference relation is defined on non-negative orthent, and the consumer circumstances limit the various alternatives he is actually able to achieve, and he has a feasible set B in non-negative orthent. B is the feasible set. Finally, we also assume that the consumer is rational to achieve the most preferred feasible alternative according to his preference relation. And formally, the consumer seeks to maximize the satisfaction by choosing the most preferred bundle in a feasible set such that the most preferred bundle is at least as good as any other bundle for all other consumption bundles in the feasible set B. Next, to make further progress, we make the following assumptions. The first assumption is that the consumer's preference relation or the binary relation is complete, transitive, continuous, strictly monotonic, and strictly convex on non-negative orthent. Therefore, the preference relation of the consumer can be represented by a real valued utility function U that is continuous, strictly increasing, and strictly quasi-concave on non-negative orthent. Let us suppose there is the two-word case. There are two goods in the real world. Preferences like these can be represented by an indifference map whose level sets are non-intersecting, strictly convex, away from the origin and increasing northeasterly as depicted in the figure below. So, in this figure, we can see that there are two goods. One is x1 and one is x2, and the preferences like these are here represented by the indifference map in such a way that the various indifference curves are non-intersecting. They are strictly convex to the origin, and they are increasing in the northeast boundary as depicted in this figure. So there is also a market for each commodity, and a price Pi prevails for each commodity I. So the consumer faces Pi for each commodity, or P vector in case of n commodity. So supposedly prices are strictly positive, so that Pi is greater than 0 for all I varies from 1 to n goods. Moreover, we assume that the individual consumer is a price taker because he is small in the overall market and he cannot exercise any influential influence on the price, so he is only the price taker. Therefore, we take the vector of market prices P strictly greater than 0 as fixed from the consumer's point of view. The consumer is endowed with a fixed money income Y which is greater than or equal to 0, and that the expenditure not exceed income can be stated as summation I varies from 1 to n Pi xi is less than or equal to I, or more compactly in vector notation, the vector of prices and vector of goods is less than or equal to the consumer fixed money income Y. And the feasible set B, which is also called the budget set, is a set of consumption bundle X such that X is in non-negative orthant, subject to uh, price vector times the commodity vector, which is less than or equal to the consumer money income, fixed money income. In a two good word, B consists of all bundles lying inside or on the boundaries of the shaded region in the figure in the next slide. So it means that the feasible set is either inside this budget line or on this boundary. So all this shaded area represents the budget set or the feasible set, which is given by this formula. The consumer's problem can thus be thought of equivalently as a problem of maximizing the utility function subject to the budget constraint. And formally, the consumer's utility maximizing problem is written as to maximize utility of the commodity consumption bundle subject to X is in a non-negative orthant, and that is subject to uh, vector of prices and vector of commodities is less than or equal to the budget line. So we may note that if the most preferred bundle X star solves this problem, then the utility of the bundle consumption bundle X star is greater than or equal to the utility of any other X for all X in a feasible set, which means that the commodity bundle or the consumption bundle X star is at least as good as X for all X in feasible set B. We have also noted earlier that under the assumptions of on preferences, the utility function Ux is a real valued function and it is continuous. So the budget set B is a non-empty, closed, bounded, because all prices are strictly positive and thus compact subset of Rn, that is orthant. We are therefore assured that a maximum of the utility derived from the consumption set X over B exists. Moreover, the feasible set B is convex and the objective function is strictly quasi-concave. The maximizer of the utility function from the consumption bundle X over B is unique. We will see that in the coming diagram in next slide. Because preferences are strictly monotonic, the solution X star will satisfy the budget constraint with equality lying on the budget line rather than inside the boundary of the budget set. Therefore, when Y is greater than 0, that is when income is positive, and because X star is greater than or equal to 0 but X star does not equal 0, we know that X star I is greater than 0 for at least one good I. A typical solution to this problem in the two good case is exhibited in the figure in the next slide. So this is the solution to the consumer's utility maximization problem. We have two goods X1 and X2. This is the budget line. The horizontal intercept is equal to Y divided by Pi, whereas the vertical intercept is equal to Y divided by P2. This is the budget line. These are the various indifference curves, that is the indifference map, and this is the solution where the marginal rate of substitution of X1 for X2 is equal to the slope of the indifference curve. So X1 star and X2 are the solution for this problem. In the below diagram, we see if we have this is the original budget line and then the price of X1 decreases, then this is the budget line. Then in that case, the quantity demanded of X1 will increase, and this basically shows the Marshallian or the ordinary demand curve. We can derive Marshallian demand curve from change in the price of X commodity when this commodity is normal. So this is the consumer problem and the consumer demand behavior. In addition to this, clearly the solution vector X star depends on the parameters to the consumer problem. So what are these parameters? Because it will be unique for given values of the price vector P and income Y, we can properly view the solution to the consumer problem as a function from the set of prices and income to the set of quantities consumption set in non-negative orthant. We therefore will often write xi star as a function of the price factor and the consumer fixed money income for all I is equal to 1 to n, or in the vector notation x star is a function of the vector of prices and the budget, the consumer fixed money income. When viewed as functions of the prices vector and the consumer's income, the solution to the utility maximization problem are known as a ordinary or Marshallian demand function, as I just showed to you in the previous slide. In this is how we derive Marshallian demand curve. So the next slide shows exactly the same thing, that when viewed as function of prices and y, the solutions to the utility maximization problem are known as ordinary or Marshallian demand functions. When income and all prices other than the goods own prices are held fixed, the graph of the relationship between quantity demanded of xi and its own prices in its own price pi is the standard demand curve for good I. Here you can see more detail. In this case we have vectors. Finally, the marginal utility is proportional to price for all goods at the optimum. All, alternatively speaking, we can say for any two goods J and K, we can combine the conditions to conclude that partial utility, the partial derivative of the utility at the optimum with respect to xj divided by the partial derivative of utility at the optimum with respect to xk is equal to the ratio of the prices of good j divided by price of k. And this says that at the optimum, the marginal rate of substitution between any two goods must be equal to the ratio of the two goods prices. And as we saw in the two goods case, it requires that the slope of the indifference curve through the X star, the consumption bundle X star, that is the solution to utility maximization, be equal to the slope of the budget constraint, and that X star lie on the budget line rather than inside the boundary of the budget line, as in figures in slides 7 that we already saw. Ladies and gentlemen, this is how we can deal with the consumer problem. If you haven't yet subscribed to this channel, kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get regular notification about my other videos that will be uploaded for you. I thank you very much for watching this video. Kindly subscribe the various videos of this channel in various WhatsApp groups so that these could reach to the maximum possible number of people. Thank you, and see you in another video.